Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Carbocation rearrangements, hydride or methyl shifts, occur to give a more stable carbocation or when the carbon skeleton changes. A change in carbon skeleton specifically means a methyl shift, 1,2-methyl shift, or alkyl shift rather than just a hydride shift. Moving on to the next step. Analyze each carbocation for possible rearrangement with change in carbon skeleton. Option A CH3, C, CH3, 2CH2 plus is a neopentyl type primary carbocation. The carbon bearing the positive charge, CH2 plus, is primary. Adjacent to it is a quaternary carbon bearing 3 methyl groups. A 1,2-methyl shift from the quaternary carbon to the primary carbocation center would move a methyl group, changing the carbon skeleton from neopentyl to 2-dimethylpropyl arrangement to a tertiary carbocation with a different connectivity. This is a classic methyl shift that changes the carbon skeleton, giving a tertiary carbocation CH3 to C plus CH2 CH3 TML2 methyl but 2-vial cation. The skeleton changes from a 2,2-dimethyl arrangement to a 2-methyl arrangement on a longer chain. Moving on to the next step. Check other options. Option B CH3 CH2 CH2 plus is a primary N-propyl carbocation. A 1,2-hydride shift gives CH3 CH plus CH3 secondary isopropyl cation. This is a hydride shift, not a methyl alkyl shift, so the carbon skeleton, 3 carbons in a chain, does not change. Option C CH3 CH CH3 CH2 CH2 plus is a primary carbocation. A 1,2-hydride shift gives CH3 CH CH3 CH plus CH3, which is a secondary carbocation. This is again a hydride shift. The carbon skeleton, 4 carbons with 1 methyl branch, remains the same. Option D CH3 CH plus CH3 is already a secondary isopropyl carbocation. It is relatively stable and has no driving force for rearrangement, also no adjacent group that could cause a skeleton change. And for the final step. Conclusion. Only option A involves a methyl, alkyl, shift that genuinely changes the carbon skeleton from a neopentyl framework to a tertiamyl framework. Therefore, the correct answer is A. Therefore, the correct answer is option A.